All right, welcome back. We've already covered the fundamentals of XML, but now it's time to level up. How do we take it from being just a simple data format and turn it into the actual backbone of cloud services? That's what we're diving into today. We're going way beyond basic syntax and getting into the advanced mechanics that make these massive distributed systems actually work. So let's jump right in with a big question. Having a well-formed XML document is a great start, for sure, but is it really enough? How do we make sure it's not just grammatically correct, but actually useful? Truly interoperable in a super complex system like a service-oriented architecture. That's the challenge we're about to solve. First up, let's tackle a massive problem that pops up the second different systems try to talk to each other: naming conflicts. Think about it. When anyone can create their own tags, how do you stop things from becoming a total mess? Just imagine this scenario, right? Two different XML vocabularies both use the exact same tag, key. One system might be talking about a database primary key, the other one, a cryptographic security key. Without any extra context, that ambiguity could lead to some really serious errors. And the solution is actually pretty elegant. It's called the XML namespace. So the crucial point here is that a namespace basically acts like a last name for your tags. It gives them a unique context, making sure everyone knows exactly which key you're talking about and preventing those dangerous collisions. The way this is implemented is surprisingly simple. You just use this XMLNS attribute to assign a short prefix like DB to a unique URI. And get this, the URI doesn't even have to point to a real website or resource. Its only job is to be a totally unique identifier. And just like that, you've solved this huge problem of ambiguity in distributed systems. Okay, so our names are sorted out, no more collisions. Let's build on that. Now we need a much more powerful way to define the rules for our XML documents. We're talking about a strict contract that both the sender and the receiver can agree upon and validate against. Now, we've touched on this before, but it's an absolutely critical distinction to get right. Well-formed just means the syntax is correct. But valid? That means the document follows a predefined business contract. And for any serious, real-world application, validity is everything. This slide really highlights the evolution from the old DTDs to the modern XSD. XML Schema, or XSD, is the standard today for a few key reasons. First, it's written in XML itself, so all our existing tools can work with it. But even more important, it supports rich data types, things like integers, dates, decimals, and it lets us create way more complex validation rules, which is absolutely critical for building robust systems. So we have a valid document, the names are clear, the rules are strict. Now, how does a software application actually read and process all this information? Well, that's where a special tool called a parser comes in. And there are two main ways to do this. Think of it like this. On one hand, you have the SAX parser, which is like the streamer. It's like listening to a live radio show. It processes data as it comes in, it's super fast, uses very little memory, but you can't rewind. On the other hand, you have the DOM parser, the architect. It's like getting a full blueprint of a building. It builds a complete map of the document in memory first, so you can jump to any part you want. But you have to hold the entire thing. So here's the bottom line, the key trade-off you really need to understand. You're going to choose SAX when you need speed and efficiency, especially with gigantic data files that would never fit in memory. But you'll choose DOM when you need the freedom to navigate, query, and even change the document's structure on the fly. Okay, but we're not done yet. Our advanced XML toolkit needs one more piece to handle a super common problem. What happens when you get a perfectly valid XML document, but it's just not in the format your application needs? Well, you don't rewrite your application, you transform the XML. And that is exactly where XSLT comes in. It's this powerful language designed for one specific job, to take an XML document as input and transform it into something else. That could be a totally new XML structure, an HTML page for a website, or even just plain text. And the process itself, as you can see here, is pretty straightforward. You take your source document, you apply what's called an XSLT style sheet, which is basically just a set of transformation rules. And then the XSLT processor spits out a brand new output tailored to your exact needs. All right, let's bring this all home. We've talked about namespaces, schemas, parsers, and transformations. So how does this whole ecosystem of powerful tools actually enable cloud computing and let different services talk to each other seamlessly? This is a super important point to remember. XML itself doesn't actually send anything. It's the structured message, the payload, that gets sent using standard internet protocols like HTTP. So XML defines what is being sent, while the protocol defines how it gets there. That separation is the absolute key to interoperability. So when you put everything we've talked about together, you get this powerful ecosystem. XML gives you the data structure, XSD enforces the contract, and XSLT transforms it when needed. And then other technologies like XPath for navigation and SOAP for messaging build on top of this foundation. This whole stack enables that platform-independent communication that is the cornerstone of SOA and software as a service. And that really is the ultimate takeaway here. Mastering these advanced XML mechanics isn't just about learning some tech. It's about understanding the universal language that literally makes modern distributed systems and the cloud itself possible. So next time you use a cloud service, just think about the complex, invisible dance of all these technologies happening behind the scenes.